So welcome back, class. We are going to continue with differentiation. So today we are going to work on how we can solve this problem. So the question is saying the equation of a curve is y equal to x minus 3 cubed minus 6x. Then item 1 is saying express dy dx and d squared y dx squared in terms of x. So this is how we go about it. Firstly, the solution, we have to say since y is equals to 2x minus 3 cubed minus 6 dy dx will be equal to 2x minus 3 squared by 2 minus 6. So dy dx will be equal to 2 by 3, that's 6 by 2x minus 3 squared minus 6. So that's dy dx. So next step, we are going to express d squared dy dx squared in terms of x. So what's d squared dy dx squared? D squared y dx squared is the second derivative of this expression. So we are going to differentiate the expression for dy dx to get d squared y dx squared, which is the second derivative. So how do we go about it? So we're going to take 2 by 6, that's 12 by 2x minus 3 by 2. So d squared y dx squared will be equal to 2 times 12, that's 24, 2x minus 3. You can actually leave it like this, or you can simply expand, but the concept is the same. So this is for item number 1. So we are going again for item number 2. Find the coordinates of the stationary points and determine the nature of each stationary point. So from our last lesson, I said that at the turning point, dy dx will be equal to 0. So to go about it, we're going to replace dy dx. We're going to replace dy dx with 0. So our expression becomes 6 by 2x minus 3 minus 6 equal to 0. 6 comes here, it comes here to add, so it will be 6 by 2x minus 3 squared is equal to 6. So divided by 6, divided by 6, 6x. So 2x minus 3 squared equal to 1, right? So we want to find the value of x. So how do we go about it? We are going to put square roots on both sides. So you are going to get 2x minus 3 because square root of 1 is plus or minus 1. So 2x will be equal to plus or minus 1 plus 3. Okay, this one will come here. So we are saying 2x, let's firstly use positive, so it will be 1 plus 3, so 2x will be equal to 4, or 2x will be equal to, we are now using the negative sign, minus 1 plus 3, that's 2. So we're going to divide it by 2, divided by 2 to 2. So x will be equal to x into 2 into 4, that's 2, then we vary by 2, x will be equal to 1. So our x coordinates, we have x is equal to 2 and x is equal to 1. Now we want to determine the nature of these turning points. So on the nature, we are going to use the expression for d squared y dx squared, which is equals to 24 2x minus 3, 24 2x minus 3, like this, right? So how do we go about it? We have our stationary points. We have x equal to 2 and x equal to 1, right? So these are we have to determine if x equals to 2 is the minimum point or maximum point. So what are we going to do here? We're going to substitute on x with 2 the first time. So d squared y dx squared will be equal to 24. 2 by 2, that's 4 minus 3, which is equals to 24. So d squared y dx squared is equals to 24 when x is equals to 2. So what are we saying here? When the value for d squared y dx squared is greater than 0, that point will be the minimum point. Then we're going to replace on x here with 1. So d squared y dx squared will be equal to 24 2 minus 3, which is equal to minus 24. Minus 24 is less than 0. So when the figure for d squared y dx squared is less than 0, that point is a maximum point. So our points here, our stationary points, we have therefore we have a stationary point x equal to 2 is the minimum point, then x is equal to 1 is the maximum point. Those are, so x is equal to 2 is the value of x when for the minimum point, and x is equal to 1 is the value of x is the minimum point at the minimum point. So yeah, that's how we go about it. So if you have any question, any problem, just ask. We can actually help.